So we have nth roots and rational exponents. What we're talking about today is rewriting things going within two directions. We're going to talk about what are nth roots, and then what are our rational exponents given the nth root. And it's really not all that complicated. What I'm going to start with is basically the fourth root of 81. Now, when you guys looked at stuff before that was the square root, you would ask yourself the question, what times what is the number underneath the radical? Now, if I'm talking about the fourth root, I'm asking what times what times what times what is 81. So what are four numbers that are the same number you multiply together to get 81?
3.
Or
Negative
3. Again, in this case here, if I'm looking to simplify this out, this means what are four numbers that are the same multiply together to get 81? Well, it could be 3, or it could be negative 3. Now, people have kind of been freaking out about this whole, why is it negative 3? Take a look at how this breaks down. Negative 3 times negative 3 is how much? It's 9. Negative 3 times negative 3 is how much? 9. 9 times 9 is how much?
81.
That's how that works. When you have an even nth root,
So that's like 3 times negative 3 times negative 3.
exactly.
Oh, that's
I treat it out a little bit. Okay, that's fine.
okay. That's right.
So what happens here is that you're asking yourself the basic question. And the other part of this is called an nth root. That's called an nth root. It gives you some value a underneath the radical, and whatever your root is the n value out front. So they write that as what's called an nth root. To rewrite an nth root into a rational expression, or all you do is take, well, let me put it in the sheet. And I'll use the fourth root of 81 as our example. This is our nth root. To get this to look like a rational expression, it's a to the 1 over n. And we've discussed this before. Remember when I talked about square root being a half power? Remember that? Maybe? Vaguely? When you take a square root, it's actually taking a half power. I think I showed you guys how to do that in your calculator real quick. It's just another way of writing it. Nth roots can be rewritten as fractional exponents. So this is the same thing as saying is 81 to the 1/4 power. That's what that means. No. It's raising it to the 1/4 power.
Yeah, which is basically dividing it
No.
by 3.
No. You're still asking yourself, what are four numbers that are the same that multiply together equals 81?
No, but like 75%, which is like 25. It doesn't work.
Yeah, your calculator has a button, has an nth root button, and people were asking about this earlier. If you go to your calculator real quick, you hit math. You'll see a button there, number 5, it says x root. That's an nth root button. If you hit number 5, it usually shows up on your screen that has answer root something. All you have to do is overwrite where it says answer by hitting the left button a couple of times and change it to whatever nth root you have. In this case, we'll say it's 4. And bring your cursor back inside. Oops. And hit enter. Now again, it's only going to give you one of the values. Yeah. No, go ahead. It's okay. Never mind that. So you have to remember what happens with some of these powers. I'm going to explain to you guys what those have, how this works. Okay? So your calculator will do this work for you. But as we get into this more here in a couple of minutes, you'll start to see that you don't need a calculator for this stuff. You really don't. To be able to do a lot of stuff in your head. Okay.
The opposite,
What's that?
the opposite.
The opposite is where things get a little bit weird, and that's where I'm getting into this stuff. And this is the nth root information, the nth root where it gets weird. Now we have fractional exponents. 9 to the 3 halves. You can, but there would be calculator or non-calculator. And this is something that you should be able to do by hand. Because what you're looking at here is you're going to follow the following pattern. For all nth root style problems, rational expression like this, if it's a to the m over n, remember that n value, the denominator of the fraction, is always the nth root. So in this case, it would be the square root of 9 cubed. What's the square root of 9? 3. What's 3 cubed? So your answer here, 9 to the 3 halves, is 27. Again, the denominator tells you what root to take of the a value. Yeah?
Which one's
M is the numerator, oh, for this one?
or no, over that? Because you have like,
A is horrible.
Oh,
N and M. The nth root, do that first, and then raise it to whatever the m power is. Okay?
or on the 9 calculator, we end on that,
The 27?
the 293.
Oh no, because this you should be able to do. What's the square root of 9? What's 3 cubed? 3 times 3 times 3.
Oh, 27.
That's what I'm saying you should be able to do. We're not going to get real complex numbers, nothing too crazy. What you see in the examples here today and the homework is about as complex as this stuff gets. There's no real reason to know how to do any other larger numbers, but you'll start to pick up on a pattern here. Check out.
I see that you, like, when you do, like, square root of 9, like, cube it.
Yeah.
Where's the 2 go?
Well, that just tells you the nth root. That just means take the square root of 9. If this was 3 out front, we would take the cube root of 9. If it was a 4 out front, you take the fourth root of 9. But obviously you can't take the fourth root of 9 because it doesn't work out even, if that makes sense. Your nth roots, when you do this stuff by hand, you're going to have numbers that'll work clean. Okay. Another example, if I'm looking at this 32 to the negative 2/5, you have to think about what it means to have a negative exponent. Is that exponent happy where it is?
no.
Where is it happy?
Denominator.
In the denominator. So you'd have to rewrite this problem as 1 over 32 to the 2/5. Again, what's the nth root for this problem? What's the denominator?
1.
5. Thank you.
Later on this other one.
Yeah, again, in this case here, my denominator is 5. So this is saying 1 over the 5th root of 32 squared. So start to think this through. If it's 5 numbers you have to multiply together to get 32, those 5 numbers should be rather small. It's 2. Because remember, we just did 3 cubed a second ago and that was 27, wasn't it? So in this case, what's the 5th root of 32? 2. What's 2 squared? 4. So my final answer is 1/4. Remember, the 5th root of 32 is 2. 2 squared gives me 1/4. You're going to have values that should be able to identify on your own. Yeah.
So, can't you just do 32 divided by 2, or do that 5 times?
You're taking a stab that you know that 2 is the right answer. And that's an easy way to check to see if it works. Okay. What happens here a lot of times is that you'll start to recognize how numbers work. This ends in an even number. It's got to get the 2 or a 4. But remember, as you're multiplying things out as you go, it gets progressively larger and larger and larger real fast. Yes, your calculator will do the whole thing for you.
No,
You're double.
Well, no, what happens, no.
He says I'm going.
No, if you divide it out, because he's right, you're right though. If you divide it out 5 times, you will get 1, because that meant that it was right. Okay? That's just, because you're breaking
Because
it
you
down.
divide it by the, because you know it's.
Because it's a fraction, one
Yeah.
over something that is equal to one.
Now here's another one. This says the cube root of -8 to the 5th power.
It's gonna be, is it I?
Well, think about this.
32i.
These are all going to be real solutions. So what are 3 numbers that you can multiply together to get a -8? It's -2. Okay? This becomes -2 because -2 times -2 times -2. Do you notice how your signs, it's an odd number of them?
Yeah,
So it's going to work. And that's one of the rules, and I'll show you here in a second. What's that?
Then you make it positive.
No. It doesn't become positive here. No. Because what are 3 numbers that you multiply together that are the same that gets you -8? Well, it's going to be -2. -2 to the 5th power means -2 times -2 times -2 times -2 times. What? It's -32. And here's one of the rules that happens here. When you're talking about your nth roots, excuse me, when you're talking about your nth roots, if your a value is positive, I'll write this out. If a is positive and n is even, not necessarily, but you can wind up with plus minus answer. Okay? If a is positive and n is even, remember, what's the square root of 9?
3.
So that's plus or minus 3. What's the 4th root of 16? Plus or minus 2. Okay? Now, these are all going to be real solutions. So if I throw this in here, can I do it? No. You would just go to the next problem, see no solution. All right? You're talking about real solutions here. Eventually, later on, we'll see some imaginary stuff. Not a lot, but later on. But to start with, we're just going to work through with this. The other part of this is if a is positive or negative, we'll do the positive one first. And n is odd. You have one answer. Really easy example. We just saw this a second ago. The cube root of 8. That's not going to be a plus or minus. It's just going to be the positive value of 2. But it also means that if I take the cube root of -8, what do I get? Negative. So what do you think my rule is going to be if a is negative and n is odd? One answer. So I'm just going to add that in now. I just wanted to show you that is a real easy example with the cube root of 8. And then the last one is if a is 0, how many roots are you going to have?
0. 1.
It's pretty easy. Okay. Not so scary. Just remember one of the things, and it goes back over time. Anytime you take an even square root, especially over an equal sign, always put plus minus. If you're taking an odd root, you keep whatever the value is underneath the radical. And that's kind of the generic way of looking at it. Okay. Let me show you a couple more examples. Uh-oh, scary stuff. Good chance. Again, we are going to solve equations using nth roots. So if I have 2x to the 4th equals 162, I got to get x all by its lonesome. What was the first thing we were going to do? Divide by 2. How do you undo 4th power? You take the 4th root.
So you just.
Because what happens if you look at that fractionally, the 4th root of x to the 4th is x to the 4 over 4, which is x to the 1st power. See how that undoes the exponent? What's the 4th root of 81? Plus or minus 3, good. Again, you took an even root over an equal sign, you have plus minus. What do you do when you have junk cubed? So when you had 2x minus 3 cubed equal something on the test last week, and you had to, it was just 2x minus 3 cubed, and you wrote 8x cubed minus 27? Probably. And a lot of other people. Cannot distribute that way, guys. That means it's junk times junk times junk.
Oh, wow.
Uh-huh. So in this case here, do I distribute the cube? No, cannot do that over the plus sign. So how do you undo it? How do you undo cubing?
Take the third.
The third root, yeah, the third, the cube root. All right, what's the cube root of junk cubed? Junk. What's the cube root of 10? Cube root of 10. I can't simplify that one.
So that's.
Not yet. Is x?
You gotta add the 2.
Yeah. All you have to do now is just add the 2 over.
Is it plus or minus?
That's equals.
Yeah. It is not, because I took the nth root of an odd value.
Oh,
I took an odd root over both sides, so all I do is just keep the sign. I don't have to do plus minus here. All I have to do is just add the 2 over. Do I need to simplify that any further? You really can't. There's no reason to, unless the instructions say round to a nearest decimal. Pretty simple.
If there's a 4th root with a negative under the root, do we also use I?
You would, but I don't think you'll have to worry about that until much later in the chapter. All right. Again, in this case here, when you're writing these out the proper way, you put the integer first, then your radicals. We'll talk more tomorrow when we get into more of the simplifying of the weird nth roots. We will be able to simplify those out. They're really not that difficult. You use the same properties as you would with square roots. But instead of looking for perfect squares, you look for perfect cube, perfect fourths, things of that. Yeah?
So will there be like a way to like find what n is or like what a is?
Yeah, eventually.
I'm scared. Maybe on the test.
But isn't that irrational?
Not necessarily, because when you're trying to find these like an exponent, we haven't learned how to do that yet. That's all. We will have eventually. We will have equations where it's 2 to the 2x equals 32. You're gonna have to solve that eventually.
Or would it be like x root 15
No.
or something equals? I'm talking about will there be any equations where it be x root?
No. That's basically what this is. We'll get there later. We're not there yet. We're not even close to being there yet. Okay. Again, these are the style that I think that you should be able to do by hand without any issues. So if you just kind of walk through it, you're going to start to see how rather easy it is if you just ask the questions. How many times have we seen the 4th root of 81 now?
A lot.
A lot. So what's the answer?
Plus or minus.
Okay. What does anything to the half power mean? What does a half power mean again? Square root. What's the square root of 49? Now, with that negative out in front, which one is it looking for? The plus minus version or what?
Just negative.
Just looking for the negative. It's negative 7. All right, now, oh, we did this one already. What's the cube root of negative 8?
2. Negative 2.
Negative 2. What's negative 2 to the 5th power?
32.
Negative 32.
Now, you did that one. You guys will get these negatives right eventually.
It's just really cheap.
I'm just hustling.
He's hustling and
Now, take a second and think about the last one.
Wow.
3,125 to the 2/5 power.
oh, so what you have to do is
So it's asking you to
use
find
that
the
formula.
5th roots. The 5th roots of 3,125,
Square.
and then you square it.
Oh, okay.
So use just properties of the numbers that you know without the calculator. What do you think 5 numbers would be that you have to multiply together that'll end with a 5?
5.
5.
125.
The 5th root of 3125 is 5. What's 5 squared?
25.
Again, what you're doing here is you're just using the power of deduction, or whatever you want to call it.
Absolute refraction.
Sure, exactly, that too. If you think about, if you're using 25, I mean 25 times 25 is already 625. You multiply it again, you're going to be well over 3,000. You know it's not going to be a 2 because it ends in 5. You know it won't be a 3 because it ends in a 5.
15.
Well, but when you multiply by 3s,
Oh, no.
you know, you're not going to wouldn't wind up there. So you kind of take a stab at it and see what happens. Okay. All right. Take a second and figure these. Oh, dead air is more fun.
Yeah.
Oh, dead.
Alive air.
Non-root. Okay, good. What do you get for 9?
Negative 1.
Negative 1. Very good. Do we agree?
Yeah, I think.
Good.
Can you go through that? I was a little.
All right, in this case here, divide out. You get x to the 5th is negative 1. What are 5 numbers that are the same number to multiply together to get negative 1? Negative 1.
Alright, I didn't think that was fun.
What do you get for 10? 0. Well, no, hold on. What do you get? Negative 4. I have 4.
I got negative 4.
I don't know why I said yes, that's right. Long. It's had a couple days off. And then lastly, for the last.
10.
Dying,
10.
Oh, I forgot.
See?
Plus minus.
Yeah, that's right.
Plus or minus 10. Again, the reason that it's plus or minus is because you have an even root. So when you take the even root over an equal sign, you have to do plus minus.
I had that. You were just looking at it and say it.
Yes, exactly.
You're so lucky.
Wait,
You
so
don't
this is the
even
test
get
that would be on the test for this part?
Yeah.
Okay, that's pretty.
What's your issue?
I didn't know that's all.
time for the search. All that time to search.
Bless you. Work through those, please and thank you. Literally gonna take you 6 minutes.
Really?
Yeah.
It'll take me like 45.
I swear to pause real fast.
Are you sure that's not every other